Safety Conference 2025. Just a few quick organizational notes before we start. So you'll see a bunch of people walking around in these black Noeon Research t-shirts. Everybody in a black Noeon Research t-shirt has kindly agreed to be event staff for the day. If you have problems, if you don't know where to find anything, if you're thirsty and need water, whatever, you can speak to specifically any one of these people will definitely be able to help you. Anyone in the Noeon Research will be able to help you. That's Caitlin or Meron-san, Blaine or Rajaza-san, and Daria or Zvereva-san. If we could raise, everybody look around, see the raised hands. These three people especially, they can help you out if anything goes wrong on the day. Just a quick run through the schedule. So right now we have the opening ceremony where you'll hear from me and you'll hear from our sponsors and some important figures from the Tokyo and Japan AI safety scene. Then we'll have our first workshop with Kanai-san from Araya and Align. Then we'll do a short poster session of maybe 30 minutes. Then we'll have a lunch break. Then we'll do another poster session. The second workshop with Mr. Cleve from Far AI. And then we'll do some closing remarks and we'll shuffle you all out of the room. There is a after party, kindly hosted by Noeon Research, happening in a separate room. If you have tickets for the after party, we can guide you there after the fact. Just before we continue, we have what I'm calling a virtual poster session, but it is an online proceedings. If you scan this QR code, that will take you to a page with all of the posters, and some of them have slideshows explaining in a brief overview of the key bits of the research. Scan this QR code, you should get to this page. I'm going to wait until everybody has lowered their phones. You can also just enter this URL. So TAIS2025.cc is our website, CC for conference, TAIS2025 the name of the event. If you go to /proceedings or hit proceedings in the top navigation bar, that will also take you to this page. And then finally, just a little map of important institutions for AI safety in Japan. I've broken this down into field builders in the middle, who are connecting industry, government, academia, grant makers. In terms of industry, we have Noeon Research and Araya, and then Rakuten AI, DeepMind, etc., who are, as far as I know, not super well connected to the rest of the scene in this room. In terms of government, we have the Japan AI Safety Institute, who we have Kid-san, who has joined us today from AC. And then we have the project team on evolution and implementation of AI, who have been writing the white paper and doing a lot of governance stuff. In academia, we have all of the large labs you would expect, Riken, UTokyo has a couple of labs, Collective Intelligence and Matsuo Lab, Whole Brain Architecture Initiative, Shibaura Institute of Technology. You'll hear from Shibaura later during the opening ceremonies. And then there are some field building organizations like Align and AI Safety Tokyo. Give us a cheer if you've been to an AI Safety Tokyo meeting. Wow, there are two of us who are currently acting as a bridge between all of these disparate industries. So you might hear these names a lot as you talk to people during the conference. Keep this map in mind to place people. So now a word from our sponsors. If I could invite Yuri from Noeon Research to say a few words.
Thank you. Hey everyone, my name is Yuri. I'm a co-founder of Noeon Research. Yeah, this is one. It's the second time that we are helping to organize this conference, and I think it's essential to have it in here in Tokyo. And it's great to have so many people here because this time we try to make it a little bit Japan-oriented, and there are still a lot of people here. That's really great. Personally think that it's essential to keep speaking about AI safety right now, even though despite last year it became less of a popular theme. I think that but the problems didn't go away. It just became a little bit less popular to speak about it. For this reason, I think it's kind of doubled as important as it used to be previously. In Noeon Research, the safety was one of our core ideas and values from the very beginning. Essentially, what we are doing is trying to build AI that is safe and robust by design. We're doing a completely deep tech research in interpretability and basically capable AI field that is white box. On contrary to the black box that is kind of domineering the space right now. That's basically it on what we are doing. If we are interested more learning about it, check our website. We always open for collaborations. We have always open position. And yeah, thank you and have a lovely day.
Hi, I'm JJ. I'm the founder and CEO of Ashgro. We are a meta non-profit research organization, which is always hard to describe, but we do physical sponsorship, which means we don't directly do the work, but we support a bunch of projects that do. We're currently supporting just over 20 projects and maybe over 60 people. I think there's a few people in the room who are part of Ashgro projects. Show of hands, anyone? Maybe not. Okay. Yeah, but if you want to know more, come chat with me. Thank you.
Can I?
Yes. Okay. Yeah. I'm sorry. Yeah. Script. Yes, hello everyone. Thank you very much for having me. My name is Yusuke Hayashi, and I'm a director at AI Element Network, ALIGN for short, a non-profit research organization recently established in Japan. And ALIGN aims to create a hopeful future where advanced AI systems that coexist harmoniously with humanity. Founded in September 2024, our goal is to build a robust ecosystem of researchers and engineers and stakeholders from academia, industry, and government sectors in Japan. And our unique vision, the human-AI symbiosis, the one key objective of ALIGN is to theoretically and empirically prove whether harmonious coexistence between humans and advanced AI is achievable. Our research includes sustainability analysis of the multi-agent systems comprising humans, AIs, and potential superintelligence intelligence systems, utilizing frameworks, much technical theoretical frameworks. And please join us in building the future that we warmly invite you to collaborate with us. And ensuring AI aligns with human values is not merely a technical challenge. It requires the globally, the interdiscrepancy, the cooperation. Together, we can build a future where AI and humanity live side by side. Thank you.
And finally, I'd like to invite Professor Tan from Shibaura to talk about.
Okay, hi there. This is done from Shibaura Institute of Technologies. So first of all, I would like to thank the TAIS 2025 organizers for their great effort to organize this event and giving me opportunity to introduce our university and also AI safety activities. Okay. So a little bit about myself. I'm a professor in SIT. My major is computer vision, deep learning, and autonomous robotics, and recently AI safety. Yeah. About SIT, or Shibaura Institute of Technology, that is the private university in Tokyo. And it's founded in 1927 by Dr. Arimoto with a mission statement about nurturing practical engineers who learn from society and contribute to society. Okay. And we have two campuses. One is in Tokyo and one is in Omiya in Saitama. Yeah. All right, so you all know that the AI is transforming our world significantly, right? And with, for example, like self-driving car or high system or something like that, or like large language model. But if they fail, then I mean, it's kind of big problem, right? So how we can, it leads to the question like, if AI becomes so powerful, why we can prioritize AI safety education? We can raise the awareness of the AI safety and use this with responsibility and ethically. So recently, in Japan, we moved it in the right direction with some action from the government. For example, we have released the G7 Hiroshima AI guidelines, or like established AI Safety Institute. And all recently, the MEX also even introduced AI use guidelines in education. For the recent study showing that half of the 50% of Chinese students using generative AI in their study. However, it also showing that most of them have no awareness of AI bias, fairness, or risk. I mean, the risk is quite low. Okay, so it means that we still lack of education or structured AI safety education in university. So in SID, we take a first step to close that gap. Okay. So recently we introduced a course, AI, artificial intelligence and application and safety in our university, which is a course in the graduate school. And in this course, we blend not only the theoretical thing, but also group discussion. Also, we invited the expert from industry, for example, Google Japan, Tokyo AI Safety, Apart Research, to come with our course to bring the new perspective from industries. And also the student in our course also have at the end, they will make the presentation, also making kind of paper-like report as a result of the course. And here example, we students been divided in different groups with the assigned topic in the course. And this is some picture from guest lectures and also final presentation. And here is some outcome from our course where the student will write a paper in a group as a kind of report. And one of the papers had been accepted in ICRL in 2025 in Singapore. So the student will fly to Singapore to present by the end of this month. Yeah. So here is some also very good feedback from students. And they said that it's kind of like, this is not only the kind of research topic, but also raise their awareness about the need of AI safety as well. Also, it supports them when for the future, when they work for the industry or even in academia. Yeah. Thank you. Yeah.
Excellent. Well, that concludes the opening ceremonies, 15 minutes ahead of time. Kanai-san, are you ready to hop into the first workshop?
Yeah, why not?
Yeah? Well, please come up.
Should I talk 15 minutes longer?
Yeah, you're welcome to. It's just so rare to run under time, you know?
Coming up. Oh, okay, good. Yeah.
Do you plan to use the lectern microphone or the wandering microphone?
I think I'll just use this one.
Yeah.
Oh, it's recording now. Okay, great. All right. Okay, let's get started. Thank you very much for organizing this event. I was also at this event last year, and it was really amazing. And so now I'm like very honored to give a talk here. My name is Ryota Kanai. I'm the CEO of the company called Araya, which is kind of neural AI startup based in Tokyo. And also I'm one of the founders of the AI Alignment Network. I have really a lot of time today. So we are currently 15 minutes ahead of time. And but since it's a very long talk, maybe at some point I'll try to take a break and then get questions from you so that we can discuss. And so mainly I'm going to talk about the concept called global workspace. Maybe some of you might have heard of it. And this theory came out of consciousness research, but recently it's also becoming popular in the context of AI, since it's a kind of conceptual architecture of how to build the so-called system 2, which is the reasoning part of AI. And so the idea is, I think most people think consciousness and intelligence are independent things, but under this global workspace theory, there might be some potential connection between them. And some people may not like the idea, but we can talk later. And also, in the second half of my talk, I also want to introduce what I'm doing in the government project called the Moonshot Program. So I'm one of the project managers of this big Japanese grant. And in that program, I'm leading a project where we try to develop brain-machine interface, and eventually we want to connect brain to brain to build something like telepathy. So but in that context, actually, this notion of global workspace plays a role. So maybe this concept itself may be potentially interesting, and it might help you think about certain type of things. And recently, I also started thinking about global workspace of the society and company and things like that. So but I try not to look too crazy or anything. Whenever people talk about consciousness in AI, I think the conversation tends to end up being sort of a disaster, and somehow people get angry at each other. And but I think I try to keep this talk somewhat reasonable. But you can tell me if I succeeded or not. Okay, and so just briefly about my company. So although we are a for-profit company, we have a research division with about 20 to 30 people, depending on the time. And then there we are interested in developing AI, but also we are interested in understanding consciousness by trying to create it. So that's the kind of one important direction, and also that's probably something unique to us. Okay, and also a little bit more about the background of the company. So this is kind of a copy from my pitch deck when I started the company. So my proposal was that the world would change towards the more neurotechnology industry in the future. So initially, I wanted to create neurotech industry by collecting a lot of brain data. At that time, I was doing neuroimaging with MRI, but the idea was once we had a lot of brain data, we might be able to use it to predict mental disease, and also in the second stage, we wanted to create something like the brain-computer interface. yeah, so just like many other neuroscientists or AI researchers, I was like really inspired by Ghost in the Shell. So eventually I wanted to have like a brain implant so that people can directly access the internet, but also I still want to connect human brains to AI, and maybe like many of you may also want to do that at some point. And then eventually, once we have like a lot of data from human brain, my hope was to also build conscious AI. So those are the like 3 main proposals I had when I started the company. But it was I wasn't very successful at raising fund by this pitch because a lot of people asked, what's the point of creating consciousness? And I don't know, if there's any investor, do you want to invest in a company that's trying to create consciousness? I don't know. I might be still very bad, but then, I visited many venture capitalists, and they asked me, what consciousness is good for, and I had no idea. So I thought that maybe I might eventually create something like goldfish, but then what is goldfish good for? And so that kind of conversation was very frustrating. And but now I have a little bit better idea about what consciousness is good for. Hopefully, I can convince you so you want to invest in me. Okay, and so that's the story behind this company. So no, I started with this very ambitious sort of vision, but then in the beginning, I had to learn how to develop business. So that was like 2015 and around that time, and so there was a big impact from deep learning. So everyone wanted to try what they could use deep learning for, and so there we had mainly automotive companies, and now many construction companies as clients, and so then before I started my company, I was completely academic. So I was, just doing research, writing papers, and then suddenly, I came back to Japan and started this company. But then, I kind of enjoyed the process of learning how to start a business, but it was also frustrating for me that what I was doing was far away from what I originally wanted to do. So I had I was struggling maybe 5 years or so, and then around the year 2020, I got this big Japanese grant called Moonshot Program, and then that program is really interesting. So the idea was okay. So there are 10 big goals and under this Japanese Moonshot Program, and then the first one is to I'm kind of trying to translate to the goal of this moonshot is to liberate humans from the limitations of body, brain, space, and time by 2050, and that's a very ambitious goal. And when that program started, nobody knew what was what it actually meant, and none of us actually knew what we should do. But then but it was really encouraging to imagine a really exciting future. So usually when you apply for a government grant or maybe raise fund from VCs, you need to think about what you can achieve next year or in 3 years or 5 years kind of already far away. But here we had to think about what kind of technology we want to build in 30 years. So then I thought, okay, that's something I was thinking when I started my company. So I thought, I should apply it and got it. And so, but the thing is, but because of this grant, I had the chance to come back to like very ambitious research. So yeah, so that was my kind of background. Okay, so from here, I want to talk about AI consciousness. So before I started my company, I was in academia, and I was doing research on how consciousness emerges from the brain. So it's probably one of the core topics in science, but sometimes people find it kind of like pseudo-science type of thing. But we were like really serious about how we can make consciousness research like real science. Okay. But also, okay, so like maybe in this community, people I think like there are many aspects in relation to like safety of AI. So we also like produce like real world solutions as a company. So there are like very specific things to discuss, and we need to like consider regulations and other things. Yeah, but on the other hand, there's also a concern about what would happen to the society once we have like very powerful AI or ASI and so on. Yeah, so that's also a fascinating topic. And then, but in that context, consciousness is also an interesting topic. Maybe nobody really worries about AI becoming conscious, but I think it's a like very typical topic in science fiction. So like usually, like a very powerful AI suddenly become aware and then start having intentions and destroy the whole humanity. And so that's kind of like typical scenario. So I think like humans have kind of general intuition about like consciousness and intelligence. But on the other hand, like, if you analyze those two concepts, they're orthogonal, right? So like, even if you have like very smart AIs, they are just machines, and they are not conscious. That's the very common intuition. And on the other hand, animals are not very smart, but still they seem to feel pain, and they seem to be aware of their environment. So in that sense, somehow biological creatures have consciousness, but machines don't have consciousness, even if they are very intelligent. So that's the kind of natural intuition we have. But for that reason, like we tend to take those two concepts as orthogonal. Okay, so from here, it's a kind of like a brief intro to the problem of consciousness. So the core problem of consciousness is called the hard problem, or you might have heard of it. So the idea is something like this. So we can study the brain, we can understand how the kind of light on the retina is converted to electrochemical signals, and then that signal reaches the brain, and then after a series of processing, the brain manages to do, for example, like object classification or detection of like faces and things like that. So it's this computation must be happening, but and also like we can understand how we can sort of translate our sensory information into language so that we can communicate with other people. So all of these things are like objectively sort of detectable sort of operations in the brain. So typically the goal of neuroscientists is to understand how the brain processes information. But the mystery is somehow like we feel something inside. So like even now, like you're looking at the slide or your phone or me, you are experiencing something, right? And so that's yeah, but that's the completely mysterious part. So yeah, but somehow like some people agree that this is a problem, and some people feel, oh, this is a kind of pseudo problem, or it's this subjective experience is completely illusory. So there's a lot of debate about this, but this becomes like an interesting question when you think whether the current AI systems have this kind of subjective experience. Probably, we don't think machines have conscious experience, but actually, like, nobody knows. And another interesting thing is, I think it's like really interesting that, like, even like expert AI researchers don't know how to implement experience of pain. So for us, pain is a like real thing, right? So everyone understands what pain is and what it feels like. But on the other hand, if we want to punish AI by implementing pain, it's a bit unclear. Actually, I got interested in this topic when I was a child, when I was playing a game. So I don't know if you know the game, Dragon Quest. So like, in the game, the characters fight with monsters, and then they get some damage. And I was really wondering like whether they are feeling any pain. It's just a change in numbers, and then but it must be similar for humans, right? So there must be some sort of like physical states changing according to some harmful event. But what's the difference? I'm kind of trying to convey the essence of like this problem. So once you start caring about like this kind of question, there's something like really missing in our current understanding of consciousness. But in a way, I think in human history, like people have been talking about this for many years. Okay, but this problem is called the hard problem because it seems it's impossible to reduce this subjective experience to a set of physical mechanisms. So of course, we can try to understand the relationship between what's happening in the brain and what people actually feel internally. But of course, it's a difficult thing to study. But there seems to be a like real explanatory gap between this subjective experience and the physical events in the brain. Okay, so typically this is the question people argue about, but my feeling is we are not making any progress on this problem. And then it's an interesting topic to discuss, and I think it's an important problem. But I think it's interesting that there are things we don't really understand. And so on the other hand, because when we talk about AI consciousness, we often worry about this internal experience. But maybe more practical question is about the function of consciousness. What is function good for? What is consciousness good for? So somehow, like evolution, kind of created consciousness. So there might have been some sort of biological advantage to have consciousness, but what is it? So that's the question. Okay, and also I want to introduce like two technical terminology. So one is called phenomenal consciousness, and the other one is called access consciousness. So this distinction emphasizes the kind of dichotomy between the internal and external aspects of consciousness. So the phenomenal consciousness is this painfulness of toothache and redness of red and things like that. This subjective experience, and then understanding this seems very difficult. So it's called the hard problem, but we want to, if we want to understand like this kind of phenomenal consciousness in AI, we have to find out a way to measure consciousness in like any system. So this is one aspect, but the other one is called access consciousness. So it's the externally observable aspect of consciousness. So for example, you can present some image to a human subject and ask the person what they saw, and then they typically report based on their own conscious experience about what they saw, and so this sort of this this is purely about the function. So in that sense, we can analyze the sort of how the information is processed, and also we can. So this functional aspect of consciousness can be potentially implemented in AI without asking the question of whether they give rise to internal experience. Okay, and so let's see. Okay, let me skip. So, but I think now something interesting is happening in consciousness research because of AI. So. Like a lot of consciousness research is built on psychological concepts or philosophical concepts. So they were often described by language, but now maybe many of you here build AI yourself, and then so you use like a lot of concepts. Typically used in AI research. So just the notion of like latent space and things like that is very already useful to sort of reinterpret existing ideas about existing theories of consciousness. So I want to sort of connect like many new emerging ideas in AI research with kind of traditional more psychological research in consciousness. And also, implementing theories of consciousness is actually a challenge. So I will introduce some existing theories of consciousness. And they are, once you try to actually implement them, they are too vague. So like a lot of ideas are, they appeal to human intuition, but if you want to implement them, you need to specify a lot of details. So that way, we can force consciousness researchers to think about more details about what they mean by certain ideas. Like even so global workspace, which I'm going to talk about later. Is a very popular theory in consciousness research, but once we think about what it means, it's very vague. So that's the point. But I think there's a kind of like a fusion of these two fields where the consciousness researchers borrow ideas from like AI research. So that's something like we're working on. Yeah, and okay. So yeah, just to give you an idea, so there's a lot of text about, so here I take an example of the so-called higher order theory of consciousness. And then, but I think it's an interesting idea, but it's a bit vague. So the main claim of higher order theory is that a system or animals become conscious of some stimulus if they have a representation, if they know that they have the representation of the stimulus. So in other words, if there's a kind of metacognition or meta-representation of their sensory state, then they become conscious. I don't know. It might be a little bit confusing, but I think it kind of makes sense, right? So in the brain, like a lot of things happen unconsciously. So you may have heard of the subliminal priming, and you have a question?
Yeah, is this related to world models in any way?
World models?
Yes. If I have would having a world model be a necessary condition for this model of consciousness?
Yeah, that's a great question. So the thing is, this theory is is, I don't know, I'm maybe overly criticizing this theory, but I think the theory doesn't really answer your question. So, but I think just having world model may not be enough.
Necessary condition.
Yeah, so I think if I apply this theory to world models, you need to have a representation or some sort of like metacognition that you have the world model. Yeah, so just having the world model by itself is not it's first order representation. But if you have some sort of metacognition about this process, then it might become conscious. But the point is, I think the question you ask is like exactly about the point I'm trying to make, which is like when we think about this kind of thing in terms of AI concept, they are not specific enough to answer questions. But I think it's really useful to think those questions and find an answer. That way we can refine the ideas in such theories. Yeah.
I'd love to ask a second question at some point, but I don't know.
Actually, like, it really helps. I don't know how to keep talking for 2 hours. So.
I'm in that. Fantastic. Does higher order here, is that a reference to higher order logics? In mathematical logic? Is it more vague than that?
Well, actually, like, I'm not familiar with the higher order logic, so I cannot comment on that.
So one thought that comes to mind, Gödel's famous incompleteness proof has statements that can refer to previous statements. So that's the so he numbers statements and then you can refer to numbered statements in subsequent statements. And so there seems to be an ability to self-reference in that sense. I guess the question, I guess there's one view that suggests that you get to this kind of higher order consciousness simply by having a mass of neurons.
Yeah.
But seeing this representation here, or thinking of the Gödel, the ability to self-refer, I wonder whether it's a property of the expressiveness of individual neurons. So does this theory tell us anything about whether you get here just by scaling, or whether you get here by expressiveness of individual nodes?
Okay. Thanks for the question. So I actually reinterpreted this theory so that we can understand it when applied to like AI and other things. So what's ambiguous about this theory is nobody knows what it means to have a meta representation, and so it's often described as representation, but I think representation is a representation, not a meta representation, right? So you have some stimulus, and then you have a neural network, and then it's kind of let's say compressed to some vector. It's a representation of the stimulus, but then if you have further process to compress this representation of the stimulus, that's still like if you combine two functions together, you just get another representation. So I think the maybe qualitatively different meta representation is to represent the process rather than the representation.
Representing internal state.
Yeah, I'm thinking about something like more functional space. So like if you if you have like a lot of neural networks, and then if you embed neural networks into kind of meta representation space, so they are meta representation because they can like every like vector in this meta representation is a function rather than a vector. So that kind of thing might happen, but I don't know. I usually have like a talk only for that thing, but I just don't describe the whole thing. Yeah.
If you really are trying to use 2 hours, I'll make one reductionist guess, and then I'll drop out.
We can come back to this one later. But I just want to check like if anyone else wants to ask a question or comment. Yeah.
Would this eventually be just a mathematical model framework that would be integrating into other functions that we have currently in existence? just like you said, like a representation of representation would just mean another form of function, which is just another mathematical framework. But then how would that mathematical framework be adjusted to be integrated into other domains and other networks or neurons or other functions or vectors we have in existence today? Are we thinking that far ahead, or obviously that might come in the future, like once we have some function in the future, like do we want to then integrate that function and adapt it to whatever AI systems we have right now? Or would it be sort of an answer to why AI behaves eventually? Or are we trying to basically find out a way that, okay, can we infuse the AI consciousness part into each domain, like each neural network that we have right now from existence? Or are we trying to explain what the neural network is trying to do? Or are we trying to enforce it to behave a certain way at the end? So it's just two things, which is...
But are you asking about this specific thing?
Yes,
Oh,
specific
okay.
thing. Like, where will this eventually lead to is my question. Like, is it going to be another mathematical model which needs to be explained as to what the current AI is doing today? And how will it integrate into all those like actual modeling frameworks that we have?
Yeah, okay. Yeah, I think we could build a mathematical framework to capture this point. So the kind of thing I'm thinking about is in mathematics, there's something called a category theory, and yeah, so you have like each neural network might be some sort of morphism or maybe a functor, but you can create like higher order things. So I think like in category theory, you have things like two morphisms and things like that. So those things may correspond to this, and also I'm maybe talking about something a bit confusing and technical, but I think having meta representation is useful for interpretability as well. So okay, so okay, let me. For example, what we have been doing concretely is to sort of classify neural networks. So we train like many neural networks on independently on different data sets. Sometimes like object classification for like speech recognition, and then that kind of like qualitative differences in the type of processing they are doing should be reflected in the weight structure. So then like we use weight as input to like a higher order neural network, and then that way this network knows like okay, so this network is detecting cars, this network is detecting faces, and so on. So that way, with this kind of high order representation, you can have a representation of neural networks, and then you can compare their qualities. So it's like a word-to-vec for neural networks or something. So like you can sort of combine different networks, and having that kind of system may be also potentially useful for developing new kind of AI system. Okay. Yeah, I feel that there's some echo. Fine. Yeah.
So, because I'm a philosopher, so I should be more precise, but higher order theory, this theory is originally, I think, higher order thought theory.
Yeah.
And so, maybe in this sense, the recent reasoning models already monitored its own chain of thought, then maybe it can be. Do you think the higher order theory, higher order consciousness is implemented?
Yeah, I think that's the main topic of this talk. So we'll get back to that one. Can you do something? Yes. So first, you're right. There are many variants of higher order theory. So originally higher order thought theory, but there are higher order, what was it, like more perceptual version. I think there is a taxonomy of higher order theories. So I'm kind of aggregating everything together. And actually the question Yeah, so in a later slide, I want to address whether current GPT models are doing like global workspace like processing. Or I don't specifically address this higher order thing, but yeah, but I think that's the kind of question like we want to ask. Okay. Okay. All right. So okay. So one thing we started working on was to find some sort of correspondences between existing theories of consciousness and.
Sorry, can we ask you to stand slightly close to the microphone? I think that's what's causing it.
Oh, okay. Whoa. Okay. It was very loud. Oh, okay. It's better? Yeah? Shall I use that one? Oh. Okay, maybe I should. Is this too loud? Fine. You don't mind hearing my voice? Okay. Yeah. So this is not like very comprehensive, but we took like 3 theories we liked: global workspace theory, information generation theory, which is my original theory, where we associated the consciousness with the kind of like generative aspect of information processing. And the last one, attention schema theory, which is also related to this kind of meta-representative aspect of consciousness. So yeah. So if you're interested, you can read the paper. So I'm not going into details, but there we try to find correspondences between like existing like AI architecture and some ideas about consciousness. And also like more recently, there's a big paper by Bartolin and others where they looked at here like recurrent processing theory, global workspace theory, computational higher order theories, attention schema theory, predictive processing, and agency and embodiment. So those are considered to be kind of key functional aspects of consciousness, and then made a list, and then like once of course none of these theories are universally accepted. So they are just theories that just existing ideas about potential functions of consciousness, but they created this list, so that way we can use this list to analyze whether certain type of AI systems possess those functions. And of course, having some of them doesn't guarantee that they have actually consciousness, but at least this is kind of useful way to sort of organize a current knowledge about potential functions of consciousness. Okay, but here, again, there are like many interesting ideas, but going into all the theories is kind of tricky. So today I want to focus mainly on the global workspace theory. One moment. How much time do I have? So it's 1 hour. 1 hour still? Oh, good. No. Actually, I'm. It's still like maybe a quarter of my talk. So Well, anyway, yeah. But I think it's great that I can talk about this in detail, like and also, I guess the point of this talk is that I can kind of stimulate you and talk about this with the people you meet today, and it's an interesting topic, and some part may be controversial, but also if you haven't thought much about consciousness, and then if you're an AI researcher, I really want you to think how you can implement these things, because that's a kind of new field, and it's very rare to find people who have actual skills in developing AI and have some academic interest in consciousness. So yeah, it's a very interdisciplinary field. Okay, so but here I'm sort of I wanted to introduce the global workspace theory, which is this is kind of like a brain version of the global workspace. So this is kind of caricature or cartoon of the brain. So in the brain, you have many functionally specialized brain regions. So some areas are specialized in processing visual information, some areas are specialized in auditory information, and some areas are more specialized in producing speech or body movement. So in the brain, there are many specialized modules, and then that corresponds to system one kind of thing. And the idea of this global workspace is once, so individual specialized modules are fast, but not very flexible. So once the sort of outcome from individual modules reach the so-called global workspace, which is the central part, then that information is called that information broadcast to other modules. So other modules can use that information to coordinate. For example, paying attention. So when you hear sound, and then if the information that the sound comes from there, that information is used to direct your attention to visual attention to that part or something like that. So basically, the idea is with this global workspace, information is shared, and then that kind of shared information gives some sort of a consistency to the agent, and then that is used. So by combining multiple modules in a coherent manner, the agent can engage in reasoning or system 2 reasoning. And then in neuroscience, people have been looking for where this global workspace is. So the typical thing people do is to compare which brain areas get activated when they consciously perceive something, as opposed to subliminally processing the information. So and often the typical areas reported are frontal parietal regions. And on the other hand, when information is processed unconsciously, actually there's a lot of unconscious processing happening in the brain. So even if when some letters are presented very briefly, and the brain, even if you are not aware, or even if you cannot report the contents of the presented letters, the brain responds to that. And so in that sense, that kind of situations are interpreted that the system 1 kind of specialized modules are used, and then the information is present in the brain, but they haven't reached the global workspace. So that's the typical idea. So another interesting thing is this theory assumes there's some sort of connection between consciousness and intelligence. So when something reaches conscious awareness in the brain, that information is flexibly used for kind of reasoning, right? So that's the idea. But on the other hand, it's as I kept saying, such theories still leave some vagueness. So we wanted to see what it's like to implement them, and also from AI community, some people started paying attention to this theory. So this is no, this image is taken from this Goyal's paper, no, from Yoshua Benjo's group, and so the idea is like you have like let's say like image processed by specialized modules, and then they are fast and they are processed in parallel, and then the output of some of the modules are like written into this shared workspace, and then the shared workspace is used. This information shared by all the modules. So that's the kind of more conceptualized version of global workspace. And their group has been testing whether having this kind of shared workspace has any advantage when added to kind of corresponding networks. So you can have like, you can create some network, but you can add this kind of shared workspace, and then they showed some usefulness of this, and also independently, Lenore Blum and Manuel Blum proposed something called conscious Turing machine. So, but their idea is also quite similar. So you have like many specialized modules, like vision and like memory and so on, and then but they kind of fight for kind of a bottleneck called in the short-term memory, and then that information is used to sort of guide the input in the next time step. So again, like this is another way to another like global workspace-like idea. And we have been also like looking at like existing AI architectures to see like if there's anything that's like a global workspace. So like one of the things we felt might be related to global workspace was the perceiver architecture. So you have kind of an internal state, and then you have like sensor input, could be multimodal, and then through cross attention with the current internal state, some specific information is taken into this internal vector, and then through self-attention, there's an update to the next time step. So it seems like you have kind of a global workspace that receives input from like many different modules, and then but this central one has kind of internal loop. So if it's necessary, the content is updated, and then but this is repeated. But so there's some similarity to global workspace. But also at Araya, you might know Kai, and Kai's team has been kind of like literally trying to implement this global workspace, especially by this multimodality is one important aspect. So in that in this specific work, his team trained an agent that operates in this kind of multimodal, like vision and sound environment, and then but for this navigation task, they kind of artificially created this kind of global workspace kind of thing, and then that information is added to the input. So that's another way to emulate global workspace. Yeah, and yeah. So, but I'm thinking, I got interested in global workspace when I was thinking how we could combine many different specialized modules to produce something an AI that's more general. So, this is like a very old figure I started using many years ago, but basically, like each neural network, each arrow is a neural network, and then like each neural network can be sort of regarded as kind of specialized modules in global workspace, and but when you so typically, like, but nowadays it's a bit different. But it used to be like very common to train one neural network to solve one task. But yeah, but if you can combine many specialized networks through some hub, then you can create a big graph of neural networks, and then so like solving a new problem is finding a path from one node to your target node. So in that sense, I started recognizing it's very important to have some sort of central hub where information from one module is translated to another. Yeah, and also another interesting realization about the brain is that typically, like in deep learning, we have more or less one path for processing information. But in the brain, it seems like there are many ways to sort of communicate between different brain regions. So this is kind of very classic old the connection diagram of the monkey visual cortex. There are many regions, and then they're like really interconnected with each other. And actually, like, it's very difficult to determine which area is higher or lower in terms of hierarchy. So they're all mixed. But it seems there's a mechanism in the brain that control the flow of information. So it seems like if you want to process someone's so recognize someone's face, maybe connection from these early areas to more like face-related areas may be made stronger. So the direction of connectivity is not always constant, but it's controlled, and so that gives some flexibility, and yeah, that's like really. Well, actually, maybe it may have some sort of link to like a mixture of expert kind of thing. So I feel like there like a lot of like new techniques that appear in AI development have like some similarity to some architecture in the brain. And so, like after thinking about something like this, with Rufan van Rulen in Toulouse, France, we wrote this paper where we reinterpreted global workspace as shared latent space. So the idea is, okay, so in the brain, there are like many specialized functions, including world models. If the world model is about predicting the next next state, but if they are connected through some shared latent space, you can use the information gained from one module to be used in another domain. So that gives like a lot of flexibility, especially when you think about producing an agent. So that way, like I started seeing there might be some potential connection between consciousness and maybe something like more AGI type of thing. Yeah, and yeah. So back then, like we were thinking that so aligning latent spaces might be like really key aspect to achieve the global workspace. Now, of course, between like different languages, even if you train a neural network independently for different languages, but after aligning, you get something like dictionary, right? So, based on the internal structure. But even like before, between like different modalities, like vision and maybe for like vision, like image captioning, like you may have to align some representations between language and images. So So that kind of thing might be happening in the brain. Actually, this kind of concept didn't exist in neuroscience before, so it's kind of interesting to think whether this kind of representation alignment is happening in the brain. And yeah, but and then this Ruffin van Rulen's group has been developing many different ways to use this concept, and then now he has a big group implementing this idea. So, for example, when we were talking, we thought about this kind of cycle consistency kind of loss. But here they found 4 ways to align representations. So let's say that you have some input coming from the kind of language model, and another input coming from a vision model, and then if you want to align their representations, there are many ways to do that. So maybe some of you might be thinking about clip, and which corresponds to this kind of relationship. So you transform the sort of modality-specific representations into something, and then you want to sort of make them similar to each other. And but they also wanted to sort of be able to reconstruct the modality-specific input and think about cycle consistency and also direct translations between them. So what they found was if you combine these things, actually this alignment works better with smaller number of pairs. So that's a kind of practical sort of improvement using some inspiration from neuroscience of consciousness. Yeah. And another interesting thing is maybe transformers are already a little bit like global workspace. So this is a paper from people at Kanai AI, and they looked at they can kind of omit some layers in transformer or replace some layers with identical ones, or interesting ones are they thought about kind of splitting the multiple layers into in parallel, or even a repeating kind of this kind of parallel processing multiple times. So, but the idea is it seems like a transformer is very flexible, in terms of kind of manipulations across layers. So, but that's mainly because you have this kind of residual connection to maintain representation. But this a residual representation seems to be somewhat consistent, and I find it somewhat like global workspace. So, although it's completely feed-forward network, but you can take the output of each layer as kind of stored in global workspace and then used by another specialized module. So each layer in transformer can be interpreted as one specific module, and then every time it comes back to global workspace and then processed differently. And so that kind of interpretation may be interesting, and especially this kind of looped parallel situation. You have up to some point you have kind of a system one thing as in global workspace, but from there if you have several experts and then if you repeat them, this kind of dynamics is very similar to global workspace. So maybe for reasoning and inference, there might be, although the appearance is very different, but there might be some conceptual connection to global workspace. Okay, and also another interesting thing is, I didn't mention this much today, but there's also a theory called predictive processing, and that might be like interesting way to implement broadcasting of information in global workspace. So you can, so for this one is like very straightforward, like image recognition network, but later network makes predictions about the input, and then but this prediction could be added to the state of like earlier layer, but simple addition tends to make this network hallucinate. So another idea was to make the kind of multiplicative attention based on the top-down prediction. So that's that kind of emulates what neuroscientists think as the predictive processing, but also like this kind of mechanism can be used to implement global workspace. So maybe it's a little bit similar to this. So here you have like latent, like shared latent representation, but you can use this state to sort of predict the input and then gate the input. So, but if it's done across modalities, it's you use information from some vision, and then but then you kind of sort of use that information to coordinate attention for auditory attention, for example. So that kind of mechanism seems also potentially useful. And so but there are like many relevant sort of ideas in AI research, and so now I feel what we should create is something like really autonomous robot that continuously learn and think with a brain-like architecture. So so when I think about consciousness in AI, I think what's critically missing is the real continuity over time. Like whenever they receive some input or prompts, they start processing something, and then especially like these days, people use this kind of like test time compute for reasoning, and that seems like very similar to kind of internal reasoning in like system 2. But then when it finishes, then this AI system is not doing anything anymore. So, but I think when some agent or robot needs to keep operating in the real world, they have to be doing. They have to be responding to like any unexpected input, but at the same time, like they have to coordinate whether they want to use their past experience for sort of updating their weights, or sometimes they should be also engaging with the environment. So that kind of coordination needs to keep happening in the real world. So I think in that sense, it's very interesting to implement some AI in real world that keeps thinking continuously, never stops. Or it might have to sleep sometimes for consolidation, but but I don't see many attempts in AI research where people. Well, of course, they exist, but I think it's an interesting challenge to implement AI that can keep operating and keep learning in the real-world environment. So then I thought about many things, and but also especially this global workspace type of thing might be like, to implement that. The idea of latent reasoning seems like very relevant. So like in current many systems, you have like output tokens to keep reasoning, but potentially you could do this reasoning just in the latent space. So for example, in this paper, you have the input. Input is kind of always fed to the latent space, but internally, you can have sort of, you can keep updating the state just in the latent space, and before like reaching some sort of output. But I just want to make this part like infinitely long, but also I want to have like instead of just one network, I want to have like many experts, and then the routing should be also learned. So depending on the current state, it needs to find the right next module to use, and then but if this agent keeps doing that, that's almost like continuously thinking. So that's something like we are trying to do next. So that's the kind of architecture. Okay, so maybe I'll stop here, and then if you have any questions or comments. Okay, so maybe you go first.
So I'm just wondering, like, if we're getting really close, or if we find ourselves approaching like conscious AI or AI that seems conscious, it seems like there's some pretty serious moral considerations there. Like, should we be creating conscious systems? Like, we might inadvertently cause a lot of pain or harm, especially because we don't understand like what that looks like and what that means. Is that a thing you're considering in your I guess process here?
Yeah, well, yeah, I think about it. Yeah, I think it can. Yeah. Well, the first thing is to like to like really create such a thing, but on the other hand, I think it's more of a theoretical possibility at this point. But I think it's really useful to think what it means to have like an AI system that looks conscious, or under certain criterion, they may be considered as conscious. So yeah, so I've been like thinking about sort of creating some sort of scale for AI consciousness, and so but also like as I showed you, there's a big list of big table of consciousness factors. So yeah, I think those are like useful first step, but on the other hand, yeah, there's no consensus about what really constitutes as consciousness. So yeah, so in that sense, I kind of struggle to make people serious about AI consciousness, but on the other hand, I agree. It is an important topic. So it may not be very important in 10 years, but definitely in like 30 years or 50 years. Yeah. Okay, there's. Yeah.
So recently we have Claude and Gemini are playing Pokemon.
Yeah.
And they're running in a loop.
Yeah.
And they have an external memory. So
Yeah.
in a sense, they're continuously running, kind of learning.
Yeah.
They're not very good at the game yet. But do you think that's along the path to consciousness that you're talking about?
Yeah, I think so. Yeah, so especially now, including the Pokemon game playing AI, it's becoming common to, or people are more interested in creating more agent-like AI. So yeah, I think that's a path towards creating conscious AI, because as I said, most people think consciousness is independent of intelligence, but I think there's some sort of convergence. So when people try to create like a very flexible agent, and then they often start showing key features of the biological conscious creatures. So I think my feeling is probably AI researchers are kind of useless in doing consciousness research, but maybe AI researchers just create conscious AI like without actually intending to do so or something. Yeah.
Hi, you were describing one of your proposals was, build this robot that can't be shut off in some sense, or only shuts off when it sleeps. Is in your model thinking about the necessity of consciousness, that concept that has to run outside of receiving user prompts, or is it more along the lines of it can't be like half on in the sense that ChatGPT can just be in a mode where it can answer your questions, but it's not updating its weights. Whereas if it was maybe a conscious mind, that's not a possible mode that it operates in. It always has to be using your global workspace and always having some feedback mechanism between doing things and updating its own weights. Could you maybe explain what is the thing that makes it not being off that makes it more conscious to you?
It's very difficult to really justify this intuition, but I think if something needs to keep staying awake all the time, they will have much richer internal thought, independent of external users. So that creates some sort of autonomy, and I think autonomy is a really key ingredient of consciousness. So that's my intuition, but also I'm not sure if I completely understood your question, but but I think another interesting thing is typically when we train AI, we separate training and inference, but when we have an agent in real time, in the real world, the agent itself needs to find the right moment to, operate in kind of learning mode or inference mode, and so I think that kind of dynamics seems like a very interesting thing to build, but I think. When things are happening just in computers, probably we don't encounter this problem. But when we have autonomous robots, then they have to operate in real time, which is continuous, and then the real environment doesn't wait for you when you have to respond. So I think I'm kind of trying to add kind of constraints of the real world to sort of facilitate that kind of development. But I think in biology, all creatures had to evolve in such an environment. So I'm kind of using the same similar kind of environmental pressure to sort of facilitate the kind of key aspect of consciousness, which I think is real timeness. But I don't know. I don't see many people talking about something like this. But if you have any idea, let me know.
Well, so when you say that, I think in terms of you could think of the universe as the user, and if the thing can't be turned off and it's always responding to its surrounding, it's like the universe is constantly prompting it in its infinite complexity, as opposed to when us mere humans attempt to use the algo, where our interaction with it is so simple that it can interact with us in a fully satisfying way without ever developing a sense of self. Whereas if the universe was the user, then it would inevitably develop that sense of self.
That's interesting. Yeah, I like the idea of thinking the universe or environment as the user prompting the agent. I haven't thought of a sense of self much, so it's hard for me to comment. Yeah, but I think I guess the main thing I want to say was that such an agent or conscious autonomous agent needs to keep operating even without prompts. So that's the general intuition I have.
I guess I'm just trying to distinguish. Isn't any stimuli it gets in some sense a prompt? What distinguishes a human prompt versus just observing and doing?
Yeah, I think they're basically the same thing. Such a robot or a system should have like a continuous video feed and sound. So in that sense, like it keeps receiving some prompts from the environment. So yeah, but I think what's potentially interesting is think of a ChatGPT that keeps running some sort of inference even without prompt, and then if it tries to learn something from it. So that's a kind of thing I'm thinking about.
Okay, thank you very much.
Okay.
Thank you for the excellent talk. I was wondering, how do you think this research into consciousness and its implementation can help people trying to reduce existential risk from advanced AI models?
Great question. Yeah, I think maybe it doesn't help, or it may be harmful if this research is successful. Yeah. So. Yeah. So, but on the other hand, I don't know, if it's a good thing to say, but. Yeah, but we may generate next generation of like conscious existence. So in that sense, in a like long-term vision, it may actually be a good thing to create more robust conscious systems, like after humans. But I don't. Yeah, so maybe some of the sort of like technical developments in the process of creating artificial consciousness may be useful for like interpreting the inner mechanisms of AI, and so there might be such practical usefulness. But on the other hand, like if we manage to create like really autonomous, very powerful AI, I think that is potentially dangerous. So I think in that sense, we have to be careful with this kind of research.
Thank you. I appreciate the honest feedback.
Maybe you want to go first.
Thanks, Glenn. So I understand from the beginning of the talk is that you felt like consciousness was likely to be necessary for developing truly intelligent AI. So first, could you confirm if that's true? And if so, do you think that, as you say, kind of the current scaling of transformers is going to create consciousness by accident? Or are we going to see at some point it hit a capability wall and then you're going to need to have systems where consciousness is more explicitly designed in?
Oh, that's an excellent question. Well, the short answer is I don't know. Yeah, so probably consciousness is not necessary, but I think there's a chance that people accidentally create artificial consciousness, by pursuing performance. Yeah.
Great. And maybe to follow up on the early gentleman's question about existential risk, I could imagine consciousness being necessary, or at least very useful to truly understand human morality, where you are sort of thinking about how someone is affected by it, and it might be harder for AI systems to reason about that if they don't have their own conscious experience. So I'm wondering if you have any thoughts on if that's sort of one of the cases where consciousness might actually help us make advanced AI do the things we want.
Yeah. Well, maybe an optimistic scenario is that they develop more empathy and they understand human pain and things like that. I think that's also true for humans. Like we understand other people's feelings by emulating other people's feelings. So we have to have the models, and I don't know whether just interfacing with humans through language is enough to develop such capabilities. So in that sense, I think it's an interesting direction to explore. But on the other hand, AI systems have very different substrate constraints. So it's always very difficult to guess what kind of thing they are thinking or feeling. Yeah, but I think at least in humans, we use something like introspection to explain our reasoning or the reasons to do certain things. So that kind of mechanism may be shared by AIs, and so eventually that might help us to trust AI. But I don't know. It's a long way to go. Yeah.
Thank you.
Okay, maybe.
So you said that there is overlap between consciousness and intelligence. My question is that what are the things about consciousness that cannot be achieved just by increasing the intelligence? Like, for example, we said, LLMs might become conscious, but in the end, it just math. So what do you think about that specific point?
Oh, yeah, that's again a really excellent question. Yeah, all those questions are very difficult to answer. So I am standing here, but I don't have a really convincing answer. But I think my feeling is that there's something we really missing about our understanding of consciousness. So as I said in the beginning, nobody knows how to implement feeling of pain, and yeah, but I think that might be actually an important question. So, well, I don't know what kind of solution we may have, but yeah, but once we understand it, there might be a really conceptual revolution, and that may change the way we think about AI consciousness. But yeah, so pain is one example where scaling doesn't reach. Yeah, so there might be such things, but okay. Okay.
Yeah, maybe just to press on that point slightly more, I think you can kind of easily imagine with today's LLMs, if you want to embody them in a robot body or something, you can have it, telling you, no, I'm in pain, stop doing this to me, ow, this hurts, have that robot body flinch or whatever. And I think what a lot of this paradigm is claiming is, no, that's not conscious, it's just faking the pain. It's fine to torture that robot. But then you add a small little layer, you add a global workspace in the middle, or you do some recurrent layers so that it's not just a feed-forward network. And now suddenly it's conscious, and it has the exact same external behavior, but now you're saying it's conscious and that pain matters. I find that perspective a little puzzling. Is that really what you're advocating? These kind of global workspace-focused approaches to consciousness are advocating?
No, yeah, so I wanted to make a distinction between experience and function. So I think this global workspace theory captures only the functional aspect, and so it's hard to say whether implementing global workspace gives rise to actual experience of pain or other sensations. Yeah, so yeah, but my feeling is, okay, my strategy is I'm interested in pain and qualia, but let's try not to focus on it. So then, for the rest, we can sort of be productive, in terms of producing something functionally useful. So that's my current sort of approach. But at the same time, I also want to be humble that there might be something we don't really understand consciousness. So, okay.
Thanks.
So early on in the talk, you mentioned like there is this global workspace theory. There's the other ones as well, like information processing. But then most of the talk is focused on this global workspace. Do the sorts of findings we've discussed here also extend to these other theories, or like is there a reason we privilege global workspace theory over the information processing theory and those other ones?
Okay. Yeah. So actually, there are many theories, and then I think they all need to be translated into more AI architecture language, and then. But I think they, often consciousness researchers argue, whether this theory is better than this theory, but they may be all integrated, and once you implement them, all those different things might be just components of a big system. So, for example, higher order theory may be a way to, maybe interpret it as kind of some sort of routing mechanism for specialized modules or something like that. So, yeah. So in that sense, yeah, I'm kind of trying to translate these ideas, but but my prediction is they may converge to more general thing rather than conceptual, conceptual different theories.
And is global workspace the most popular one?
Global workspace is very popular, but personally, I didn't like the theory for a long time because it felt like just describing what's happening in the brain. So it looks like a kind of interpretation rather than a theory. And so for it to be a theory, it needs to make interesting predictions and it needs to be precise. And but here, like when you take kind of randomly connected neural network. Nobody knows where to find, how to define global workspace. So, there's no mathematical definition of a global workspace. So that's again kind of weakness. So especially if I want to claim having a global workspace is necessary and sufficient condition for an AI system to be conscious, but then there are infinitely many variations of architecture, and then. Sometimes we have to interpret, which but that's an external viewpoint, and so in that sense it's it's very conceptual, and so in that sense it's not the kind of final answer, but it's just a very popular one because it appeals to the intuition of many researchers. There were a few more hands.
So, is it okay to say that you are only concerned with access consciousness rather than phenomenal consciousness?
Yeah. For now, yeah. I have another talk on phenomenal consciousness, which is additional 30 minutes or something, but but I care about phenomenal consciousness, but in the context of implementing, it's not really straightforward to reach meaningful conclusions. So.
Yeah, so the notion of phenomenal consciousness itself is so problematic. So I think because it's just only conceptual problems. It's totally independent of the technical problems. So I recommend you to forget about phenomenal consciousness. Really.
Yeah.
Even we don't know whether there is a human phenomenal consciousness at all. Many philosophers say we are zombies. So nobody has ever measured phenomenal consciousness. So it's totally conceptual problems through and through. So I think it's really a matter of, as you mentioned, conceptual revolution. That we should maybe in future we use commonly attribute consciousness to AI systems. But because it's conceptual problems, I think technical technological questions, we should be only concerned with access consciousness?
Yeah, I think in my case, for practical reasons, in this kind of talk, I stick to access consciousness because it's difficult to get very productive discussion about phenomenal consciousness. But on the other hand, I don't. Yeah, I know some people think it's an illusion, and but also there might be a lot of discussion to have about the validity of the notion of phenomenal consciousness or qualia. So I often get involved in that kind of conversation. But but I think the important thing is to gain new kind of perspectives about how to think about consciousness. So I think the question is there, and then a question of phenomenal consciousness is there, and then but people may have different kind of answers. You can eliminate the question altogether by conceptually analyzing phenomenal consciousness. But but I think my feeling is we can still make conceptual progress by thinking about it, and but it always will remain a controversial topic. But so I kind of disagree that we should completely forget about phenomenal consciousness. But on the other hand, I agree that focusing on access consciousness is a really useful and important thing to do. Just one more? Yeah.
Thank you. This is so going back to the question of pain. If I understood properly, the suggestion was that possibly in order to achieve consciousness, we need to implement some sort of pain stimulus in electronic systems. I guess in biological systems, there's an alignment between sensation in the first place and then the perception of the sensation, and that's mediated through electrical signals that are, or chemical signals that are received by particular receptors. So there's nothing intrinsically painful about a sodium channel being active. It's in the conscious biological entity, it's experienced as pain. So I guess within an electrical or an electronic, a silicon-based system, why don't we think that simply a large number in the loss function that propagates back through the system is equivalent to a sodium channel propagating a signal down a network? So from this point of view, rather than pain being a necessary condition for consciousness, consciousness is what experiences the negative signal as a painful signal.
Yeah. I see. Yeah. Well, yeah, that's interesting. Yeah, because of what you said, I started thinking maybe backpropagation is a torture for AI or something. So maybe training AI models is.
It's avoiding negative stimuli.
Yeah, might be. Yeah, but I think there might be some sort of functional explanation. Yeah. So eventually, I think there might be some sort of identity or so isomorphism between what we can functionally observe and what it feels like from the inside. So they might be just one and the same. So like sometimes people talk about Yoneda's lemma in category theory, and then I think that's a really interesting perspective. I don't really understand the details, but the claim is really intriguing, which is object or something itself is identical to its all relationships to other things. So in the same way, the qualia or subjective experience might be such an object or such a kind of entity, but then that's completely defined and identical to all the things it's related to other things. But this the set of relationships is like really huge. So it's very difficult to verbalize or describe everything. But but this kind of sort of correspondence between like thing itself and all the relationships might be applicable also in the brain. So like the role of one neuron in the brain is okay. It may generate some sensation, but that quality is determined by its relationships to all other things, or something like that.
Thank you. After listening to everybody's perspective and the presentation up so far, I just have one question, which is really simple, but at the end of the day, I think it just boils down to that one representation factor, which we've been talking for the past, I think, hour or so. Like the person over there, I don't know your name, sir. Thank you. So as he was saying as well, at the end, we're biological beings. And we're trying to map our consciousness, let's say, into a mechanical object, which does not have the sensory inputs which we possess, as well as the consciousness part of it, which comes on top of whatever is built into our systems, which we do not even understand after all these thousands of years, for example. Even in neuroscience, we do not understand what the brain is capable of, how it works, and what are the limitations and the boundaries of the space in which this biological thing operates. Even as I'm talking, I don't even know how I'm saying stuff. It's just coming to my into my mouth right now. So what I'm trying to say is basically, at the end of the day, no matter what we treat as consciousness in the biological domain, we have to mathematically map it to some sort of mathematical framework or representation. So the moment we utter this, doesn't it defeat the purpose of true consciousness?
Can you repeat the last bit?
The moment we say that we're translating something biological into a non-biological thing, isn't that defeating the purpose of consciousness to its true core? Like, the reason artificial intelligence is called artificial intelligence is because it's not real in the first place. Is my perception of it. And the moment we say we are translating a human into another, let's just say, algorithm, for example, we are mapping its states into nodes and graphs and everything else. So the sense of the essence of consciousness, I think, goes away the moment we translate it to.
So are you saying like consciousness is kind of like a socially attributed to other things? So like it's difficult to have direct experience of other people or other AI agents. So in that sense, like we use kind of like inferences about other AI or other creatures' consciousness, but then we can never be sure. So that's
it's a biological thing, and we're mapping it to a mechanical thing.
Yeah.
So is it really conscious in the mechanical domain? Like, can we really confidently say, like, yes, we made something conscious, even if one day, 100 years in the future, we do end up making something that's really similar, but can we say with confidence that is it really conscious?
Yeah, I think it's always going to be a wild guess. So we need So maybe like even like 100 years ago later, we may have like different versions of theories of consciousness, and then we make inferences about consciousness of AI based on those theories, and then those theories may be maybe partially accepted under certain conditions in humans, like maybe something changes under anesthesia, and then some mathematical theory precisely describes the presence and absence of consciousness in humans, and so that is that theory is validated, and then we can sort of extrapolate that theory to other things like AI, but we never know whether it's true. So that's probably a likely situation. Yeah. So maybe since I have like 3 minutes left, so maybe to answer that, I want to talk about this thing, just one. Yeah, so I think so this twin sister were congenitally conjoined, so their brains were directly connected, and somehow they seem to be able to share experience directly through the brain, and so that. Well, of course, how to interpret this is a very controversial issue, but I think, but we feel we might be like really limited in terms of our own consciousness, because our brains are all separated, so we don't have that direct connections. But on the other hand, we have like left brain and right brain, and they are connected together to make one conscious entity. So, if we connect like many brains, we may be able to share conscious experience of other people, and eventually, if you connect brain to an AI system, we may be able to feel something in the AI system. So that's difficult to imagine, but this example shows like this kind of qualia sharing may be possible. So I wanted to, I have many slides, but we are trying to connect like brains to brains, like of course recording from one brain and then translating to another brain and then stimulate, and so that's already working in animals. So in that way, eventually we may be able to create like high bandwidth connectivity between different brains or brain and AI systems. So then we will see what we will feel, and so that's the But if you are interested, we can talk about it. Since I'm running out of time, so maybe if you want to continue the discussion, I will be around. So just talk to me. All right. So that's all. Thank you very much. Okay, thank you.
Thank you. We're now going to transition. Excuse me. We're now going to transition to the first poster session. I'd like to kindly request that if you're in the back 2 rows, if you could stand and move your bags further forward in the auditorium, there should be enough free spaces so that we can collapse the last 2 rows of seating to make more room for the posters.